When we balance equations, what we're trying to do is get the same number of atoms of each element on the reactant side and the product side. So use these arrows as if they are equal signs. You need to have the same number of, for example, with number 1, magnesium atoms on the reactant side as you have on the product side. Now, on the reactant side, I have 1 magnesium, and on the product side, I have 1 magnesium. But on the reactant side, I have 2 oxygens, and I only have 1 oxygen on the product side. So I'm going to put a 2 as a coefficient in front of this magnesium oxide. Now that's going to change the number of magnesium atoms I have on the product side, but it's also going to change the number of oxygen atoms I have on the product side. And it's easy to fix that by putting a 2 as a coefficient in front of magnesium, and then I have a balanced equation. Now for the next one, we have zinc reacting with silver chloride in order to form zinc chloride and silver. Since I have 2 chlorines on the product side, I'm going to put a 2 in front of the silver chloride in order to balance the chlorines. Now I'm going to balance the silver by putting a 2 in front of the Ag. For number 3, the oxygen atoms are already balanced, but the sulfur atoms are not. There's an 8 for a subscript on the sulfur atom in the reactant side. So I'm going to start by putting an 8 for the coefficient in front of my sulfur dioxide in the product side. And when I do that, then I have 8 sulfur atoms on both the reactant and the product side, but that changes the number of oxygen atoms I have. And that's an easy fix by putting an 8 for a coefficient in front of the oxygen. And then my atoms are balanced. For number 4, we have more elements here. So we're going to make a chart: sodium, oxygen, hydrogen, and sulfur. And I'm going to count on the reactant side and the product side. So on the reactant side, I have 1 sodium, and on the product side, I have 2. On the reactant side, I have 5 oxygen. There's 4 with the sulfate, and there's 1 with the sodium hydroxide. So there's a total of 5. And there are 5 oxygen atoms on the product side as well. For the hydrogen, there are 3 atoms on the reactant side and 2 on the product side. For sulfur, there's 1 on either side. So really what isn't balanced here is the sodium and the hydrogen. Now I can't avoid changing oxygen when I change my sodium and my hydrogen because they are together. So I'm going to start with sodium, and I'm going to put a 2 in front of my sodium hydroxide. That changes the number of sodium atoms to 2 on the reactant side, and it also changes the number of oxygen atoms. Now I have 6. And now I have 4 hydrogen atoms. So that leaves the oxygen and hydrogen to be balanced. So in order to make 4 hydrogen and 6 oxygen on the product side, I'm going to put a 2 as a coefficient in front of water. That changes my hydrogen to 4, and it changes my total oxygen to 6. There are 4 oxygen atoms here, and now 2 here, for a total of 6. Now my chemical reaction is balanced. For number 5, when we have this synthesis reaction of carbon monoxide and oxygen forming carbon dioxide, first our carbon is balanced. So whatever we do in front of the carbon on the product side, we have to do to the carbon on the reactant side. So let's count our oxygens. We have 2 on the product side, but we have 3 on the reactant side. If I put 2's in front of these 2 chemicals, then I have 2 carbon atoms, and now I have 4 oxygen atoms, which balances the reaction. Number 6, we have potassium, hydrogen, and oxygen. On the reactant side, I have 1 potassium, and on the product side, I have 1 as well. I have 2 hydrogen atoms on the reactant side, but 3 on the product side. And I have 1 oxygen on both the product and the reactant side. So how am I going to get those hydrogens to balance? Well, it would be convenient if I could decrease this by 1, if I could basically cut it in half, but I can't do that because A well-balanced equation is the lowest whole number ratio of coefficients in front of the molecules. So if I multiply everything here through by 2 in order to get rid of this fraction, then I have coefficients of 2 here because the absence of a coefficient is the number 1, not a 0. And then I have a balanced equation. Let's double check. I have 2 potassium atoms on the reactant side and I have 2 on the product side. For hydrogen, I have 2 times 2 or 4 hydrogen atoms on the reactant side, and I have 2 from KOH and 2 from my H2, so I have 4 hydrogen atoms. I have 2 oxygen atoms on the reactant side and 2 on the product side, and I have a balanced equation. So you can use that fraction technique when it's just one oddball sticking out and not working for you. For number 7, we only have hydrogen and oxygen. We have 2 hydrogen on the reactant side and 2 on the product side. We have 2 oxygen, but we have 3 oxygen on the product side. And this is another example where it would be very convenient if we could just cut this in half, but we can't do that. And because we can't do that, we will multiply the other 2 chemicals coefficients by 2. So that gives me 4 hydrogens on both the reactant side and the product side. It also gives me 4 oxygen atoms on both sides. Now for number 8, we have iron, oxygen, and carbon. So on the reactant side, we have 2 iron, and on the product side, we have 1. For the oxygen, we have 4 on the reactant side and 2 on the product side. And for carbon, we just have 1. Now, since iron is alone over here on the product side, I want to leave him alone until the very end. So I'm going to look at this carbon dioxide. I want to put a 2 there. And I want to put a 2 there because that corrects this oxygen. It also changes my carbon. Well, in order for me to change carbon, I have to change my oxygen. So now I feel like I'm getting stuck. What am I going to do? Analyze the number of oxygen atoms you have. And notice that we can only work in even numbers of oxygen atoms. So 4 didn't work. Well, what if I aim for 6 oxygen atoms? If I aim for 6 oxygen atoms, that means I put a 3 here. That means I have 3 carbon atoms. So I need a 3 here as well. Now I have 6 oxygen atoms on the reactant side. Now balancing iron is very easy. Number 9 is a combustion equation, and this gets a lot of students, so I'm going to give you a trick. If you have a combustion equation and you have an even number of carbon atoms, immediately put a 2 as a coefficient in front of the hydrocarbon. Then balance the rest of your chemicals. So carbon, hydrogen, and oxygen is what we have. And on the reactant side, now I have 8. So in order to make 8 carbons, I need to put an 8 here. Now for hydrogens, I have 20 hydrogens on the reactant side. In order to get 20 hydrogens, I must have a 10 here. So now let's count oxygen atoms. On the product side, I have 8 times 2, which is 16, plus 10. So I have a total of 26 oxygen atoms on the product side. In order to get 26 oxygen atoms on the reactant side, this must be 13. And you see that cannot be reduced any farther because 13 is a prime number. So that's just a quick way to balance a combustion reaction if you have an even number of carbon atoms. That only works for an even number. Number 10 is going to be very easy in comparison. So we have 2 nitrogen atoms on both sides. We have 4 hydrogen atoms here, so I'm going to put a 2 here so that I have 4 hydrogen atoms on the product side, and that balances my equation because I also have 2 oxygen atoms. Number 11 is also easy by comparison. So I have 1 sodium on the reactant side, but I have 2 sodiums on the product side. So immediately I want to put a 2 here in front of this sodium bicarbonate. So now let's check the rest of our our elements. So I have 2 hydrogen atoms on the reactant side. I have 2 hydrogen atoms on the product side. I have 2 carbon atoms on the reactant side. I have 2 carbon atoms on the product side. I have 6 oxygen atoms on the reactant side because my coefficient 2 times my subscript 3 is 6. So I have 6 oxygen atoms there. I have 3, 4, 5, 6 oxygen atoms on my product side. So this is a balanced chemical equation. Number 12, I have P, O, and H. And on the reactant side, I have 4 P's, and on the product side, I have 1. So immediately I want to put a 4 there. When I put a 4 there, then I have 4 phosphorus atoms on the product side. I have 10 oxygen atoms. Oh, no, I don't. I have 11 oxygen atoms on the reactant side. On the product side, I have 12. Now, I'm not quite ready to put a 2 here, but I'm kind of ready to put a 2 here. And when I do that, that brings my oxygen to 12. Hydrogen, now I have 4. And I miscounted. This isn't 12, this is 16. I knew that wasn't looking right. So we have 16 oxygen atoms. We had 11. I need to up that. You know what? I am not going to put that 2 there. I'm going to wait. So I do have 2 hydrogen atoms on the reactant side, and I have 12 on the product side. So now I want to put a 6 here in order to make this a 12, and that changes the oxygen on my reactant side. So now I have 10 oxygen from my first chemical and 6 from my second to give me 16. And this is a balanced equation. Remember, the lack of a coefficient is a 1. Within the classroom, you may have to put 1s there if you have blanks. Number 13, so I have a B, E, C, H, and O. There are 2 BEs on the reactant side. That means I want to put a 2 here so that I have 2 BEs on the product side. For carbon atoms, I have 1 carbon atom on the reactant side and 1 on the product side. For H's, I have 2 on the reactant side, and I have, there's 4 here, and 2 plus 4, I have 8 on the product side. That immediately makes me want to put a 4 here in order to balance the hydrogen atoms. So now I have 8 hydrogens on both sides, and now I can count my oxygen. I have 4 on the reactant side, I have 4 on the product side, and this is a balanced chemical equation. And number 14, so I have magnesium hydroxide reacting with nitric acid. This is an acid-base reaction. And I have Mg, OH, and N. So magnesium, I have 1 magnesium on both sides. I'm going to leave those alone. I have 2 oxygen. I have 5 oxygen on the reactant side, and I have 7 oxygen on the product side. I'm going to leave those alone for right now too. I have 3 hydrogen on the reactant side and 2 on the product side. And for nitrogen, I have 1 nitrogen on the reactant side and I have 2 on the product side. So immediately I want to put a 2 in front of my nitric acid. That's going to change my H, N, and O. So now on the reactant side, I have 2 plus 6 is 8 oxygen atoms. I have 4 hydrogen atoms and 2 nitrogen atoms. So that H and O needs to change here so that we can balance this. If I put a 2 here in order to balance my my hydrogen, then I have 8 oxygen, and that is the balanced equation. For number 15, we'll use the same method. This is a redox reaction. Number 15. In order to solve number 15, we need to count our H, N, and O. Since Cu is alone, we can deal with Cu later. So we need to notice a couple of patterns. First of all, the only hydrogen we have has to be even because we only have hydrogen in an H2O. So we have 2 on the product side hydrogen atoms, and 1 on the reactant side. So immediately I want to put a 2 there. And putting that 2 there balances our hydrogen. So now let's count nitrogen. Now I have 2 nitrogen on the reactant side. I have 3 nitrogen on the product side. Oxygen, I have 6 on the reactant side, and I have 6, 7, 8, 9 on the product side. So I definitely need to change something with this reaction. Since it's not balanced by going with 2 hydrogen, I'm going to try it with 4. Now remember, we have to work in evens with our hydrogen because of the H2O. So I'm going to change these 2 coefficients and recount our HN and O. So on the reactant side now I have 4 hydrogen, and on the product side I also have 4. For nitrogen I have 4 nitrogen, and it didn't change on the product side. But for oxygen I have 12 oxygen atoms, and here's 3 times 2 is 6, 7, 8, 9, I have 10. So now it's the nitrogen and the oxygen that need balanced. So if I put a 2 here and then recount my nitrogen, so now I have 4 nitrogen on the product side, and now I have 6 plus 4 plus 2, or 12 oxygen. Now this is a balanced chemical equation. We only have 1 copper on each side, so this is all I need.